Ever wondered how your car seems to know everything that's going on? From adjusting your seat to deploying an airbag. It's not magic, it's a system called the CAN bus. Today, we're diving deep into the nervous system of modern vehicles. Picture this. It's the late 1980s. Cars are getting more features, Abes. Electronic fuel injection, power windows. Each new feature needed its own dedicated wiring. You ended up with a tangled, heavy, and expensive mess of copper wires running all over the car. It was a nightmare for both manufacturing and repairs. A simple electrical issue could take days to diagnose. There had to be a better way. Enter Bosch in 1986 with a revolutionary idea. The Controller Area Network, or CAN bus. Instead of a spider web of individual wires, CAN bus uses a simple twisted pair of wires to create a network. Think of it like a group chat for your car's electronic components, or what we call electronic control units, or every ECU. Whether it's for the engine, transmission, or your radio, is connected to this network. When one ECU wants to send information, it broadcasts a message onto the network. For example, when you press the brake pedal, the brake controller sends out a message saying, "Hey everyone, the brake is being applied." Now, here's the clever part. Each message has a unique ID that tells everyone what kind of information it is, like engine speed or wheel rotation. Other ECUs on the network listen for the messages they care about. The instrument cluster, for instance, is listening for the engine speed message so it can update your tachometer. The apps controller is listening for wheel rotation data to detect if a wheel is locking up. It's an incredibly efficient way to share data. This design has some huge advantages. First, it drastically reduces the amount of wiring. This makes cars lighter, which improves fuel efficiency, and it also makes them cheaper to build. Second, it's incredibly reliable. The twisted pair wire design is resistant to electrical noise, which is everywhere in a car. And if one ECU fails, the rest of the network can often continue to function without it. The CAN bus also makes diagnosing problems much easier. A technician can plug a diagnostic tool into the car's OBDII port, which connects directly to the CAN bus. From there, they can listen in on the conversation between all the ECUs, read error codes, and see real-time data from every sensor. This turns a week-long diagnostic headache into a matter of minutes, as cars have become more complex. With advanced driver assistance systems like adaptive cruise control and lane keeping assist, the CAN bus has become even more critical. These systems need to react in milliseconds, sharing data from cameras, radar, and other sensors. The engine needs to know what the transmission is doing. The stability control needs to know how fast each wheel is turning. And the infotainment system needs to know if a door is open. The CAN bus is the high-speed backbone that makes all of this seamless integration possible. So next time you're driving and your car automatically adjusts its speed or warns you about a car in your blind spot, take a moment to appreciate the unsung hero working behind the scenes. The CAN bus is the digital nervous system that transformed our cars from simple machines into the intelligent, safe, and efficient vehicles we rely on every single day. It's a brilliant piece of engineering that keeps everything connected. Thanks for watching. If you found this interesting, hit that like button and subscribe to Code Mechanic for more deep dives into the tech that powers our world. See you in the next one.